A classic application that involves the square root property is the Pythagorean theorem. Okay, so the Pythagorean theorem is used to find the length of a missing side of a right triangle. So hopefully you know what a right triangle is, but just in case you have forgotten, a right triangle is a triangle that contains one right angle, or at least 190, well, not at least, it has exactly one 90-degree angle. Now, hopefully you can see this image pretty well, but the two sides that make up the right angle are called the legs of the triangle. So this is leg A, this is leg B, and then the diagonal, the longest side of the triangle, the side opposite the right angle is called the hypotenuse, and the hypotenuse is always C. So like when you very generically label a triangle A, B, C, A and B are the legs of the triangle when you're dealing with a right triangle, and C is the hypotenuse. Now, the actual Pythagorean theorem states that if you take the sum of the legs squared, it should equal the hypotenuse squared. So that just means if I take A and square it, add it to B squared, I get C squared. So quite literally, the Pythagorean theorem is A squared plus B squared equals C squared, where A and B are called the legs of the triangle again, and C is called the hypotenuse. Okay? Now, the way we can use this, there are so many applications involving the Pythagorean theorem. So we're going to look at just a couple of basic ones, okay? So example 2 says use the Pythagorean theorem to solve, include units with your answer. So we have that the base of a 25-foot ladder is placed 10 feet from the base of the wall. So kind of the bottom of the triangle is 10 feet away from the base of the wall, and the triangle itself is 25 feet. So what happens is if this is the wall, and we'll say this is the grass, we have this 25-foot ladder. Well, let me redraw that. That's not anywhere close to what we want it to look like. So we have this ladder. We're going to say this is the ladder. Okay, we know it's 25 feet long, and we know this distance from the base of the wall to the foot of the ladder is 10 feet. What we want to know is how far up the wall does the ladder end up laying. So we want to know what this distance is. So remember, the legs of the triangle are always A and B, and the hypotenuse is C. So we could say that this right here is C. We could say this is B, and the side that we don't know, let's just say it's generically A. Now, when it comes to the legs of the triangle A and B, it does not matter which one you call A and which one you call B. Just make sure the legs are A and B and the hypotenuse is C. Okay? Now, we want to plug this into the Pythagorean theorem. So A, we don't know. So we're just going to say if I take A squared and I add it to B, which is 10, and square that, it has to equal C, which is 25 squared. Okay? And now we want to work at solving this. So A is just A squared. We don't know what that is yet. That's what we're solving for. But we do know that 10 squared is 100. And 25 squared is what? Is that 625? Let's double check really quick. 25 times 25 is indeed 625. All right, so now we want to try to solve for A squared. So remember, when we have the square root property, we want to take the variable and it needs to be in a single term. So all of the variable component needs to be in a single term squared, and we want to isolate that. So we want to subtract 100 from both sides. Well, 100 minus 100 is 0, so that leaves me with just A squared. And then A squared equals, well, 625 minus 100 is 525. Now, at this point, it kind of depends on what your answer is going to be, so read the directions in the problem. We do know at this point we want to take the square root of both sides, okay? So the square root of A squared equals plus or minus the square root of 525. And what I mean by at this point, you need to be careful and read the directions. Sometimes the directions are going to ask you to round your answer, which means just run to the calculator, figure out what the square root is, and round it. Other times they may want an exact answer, which means you would want to simplify the radical. This one doesn't specify, so let's just go to the calculator and figure out what the square root of 525 is. So the square root of 525, and let's round it one decimal place, is 22.91287847. There's more decimal places after that. But let's just round it one decimal place. So after the decimal, we have a 9. To the right of that, we have a 1. That tells me that this is going to round down, meaning I leave the 9 alone. Everything after that, I just chop it off. Okay? So we would then say that this is, well, the square root of A squared is just A. And then we get plus or minus 22.9. Now, let's think about this. We have negative 22.9 and positive 22.9. One of those answers just doesn't make sense in this application. We're talking about the distance up a wall. Distance can't be negative. So in this case, we don't need the plus or minus. We just need this to be the positive. The negative 22.9 doesn't make sense. This ladder isn't going to be negative 22.9 feet up the wall. It's going to be positive 22.9 feet up the wall. So we can then say that this distance right here is approximately 22.9 feet. Okay, so even though in generic problems that plus or minus really matters, in application problems you have to think about, does the positive make sense? Does the negative make sense? Oftentimes you throw out the negative. Okay, let's look at part B. A TV is measured by the length of the diagonal. Did you know that? Okay, Hannah has a TV that is 20 inches tall and 21 inches wide. What is the length of the diagonal? So here's the TV. This is not by any stretch of the imagination drawn to scale, but we're going to say it's 21 inches wide. Well, let me see. I have it backwards. It's 20 inches tall and 21 inches wide. What we need to know is what is the length of this diagonal. Okay, so let's say A is the width. Let's say B is the height. Let's figure out what C is. Okay, so remember it's A squared plus B squared is C squared. So A is 21 squared plus B, which is 20 squared, equals C squared. We don't know what C is yet. Okay, so let's see. You might know 21 squared and 20 squared, but if not, let's go to the calculator. So 20 squared, hopefully you know that one. That one's pretty common. That one is 400. 21 squared you may not be as familiar with. So 21 squared is 441. So remember those. Okay, so we have 441 plus 400 equals C squared. Well, we want to go ahead and add our 441 and our 400, so we get an 841 equals C squared. Okay, now we want to get C alone, so at this point we would take the square root of both sides. So the square root of C squared equals plus or minus the square root of 841. Let's go ahead and figure out what the square root of 841 is. That's not something I would expect you to know. So the square root of 841 is, whoops, the square root of 841. 841, there we go. And let's again just round one decimal place. Well, in this case, it's just 29, so that works out nicely. So let's go back to the worksheet. And we get C squared, the square root of that is just C. And then we get plus or minus 29. Well, can the length of a diagonal of a TV be negative 29 inches? No, that doesn't make any sense. So we would just say that C equals 29 inches. So again, when you're dealing with these real world application type problems, oftentimes the negative square root doesn't make any sense. So when you do the square root property, you can still solve it generically using the plus and minus, but you typically throw out the negative. So we would say here, the diagonal of this TV is 29 inches. Okay, so that is an application involving the square root property. What we're going to do in our last video for this worksheet is an application of the Pythagorean theorem. Okay. So meet me back here for that one.